Hello and welcome to Channels for Nextflow podcast. You're listening to episode 23, going out on September the 25th, 2023. My name is Phil Yules. I'm a developer advocate at Seqera Labs. I'm sat here in Sweden today in Stockholm, and we're going to be talking to you about all the latest and greatest Nextflow community items. With me today, we have Marcel. Do you want to say hi, Marcel?
Hello everyone, I'm Marcel. I'm speaking to you from Brazil. I'm a developer advocate at Seqera Labs. I'm glad to be here again.
And thanks for joining us. It's pretty early for you, Marcel, so thanks for setting your alarm early. Apologies for the calendar scheduling. But joining us today, I'm very happy to introduce Paolo Di Tommaso. Go on, say hello, Paolo. Who are you?
Hi, I'm Paolo, CTO of Seqera Labs and creator of Nextflow. And very happy to join you into this podcast.
A man who needs no introduction, really, but yeah. We've been talking about doing this episode for a while, actually. I'm quite excited. We're not going to talk so much about Nextflow itself, but we are going to talk about something that Nextflow loves. We're going to talk about containers, container technology, and some of the kind of cool new things that we're pushing the boundaries with a little bit. Maybe, Paolo, can you just start us off and tell us a little bit about what containers are, why they're good, why they're useful, and how we're using them already with Nextflow?
Yeah, sure. Containers are key component in modern software architecture because allow us basically to capture and create a container that contains all the pieces of software that we need to run into an application or maybe into a pipeline. So, and for Nextflow was a very important design choice because allow us to allow Nextflow pipelines or allow us to basically isolate the job execution into pipeline into independent container. So, and the container made it possible to assemble a package that contains all the software dependencies. And this was a big jump forward because until previous day usage container, basically when you need to run a pipeline into a computer or cluster the computer, there was this huge problem to have to configure all the pipeline dependencies, the tool used by the pipeline, one by one. And this can seem trivial things, but when you have a pipeline with 20, 30, 40 different pieces of software, each of them are very different specific version or specific configuration of variables. So configuration file is a real nightmare. It's a real big problem. And one central idea that we had with Nextflow at the beginning was but let's try to use container. At that time was quite new technology because we are talking about 2013. Well, basically, container exists already before because it was a technology created by Google. But that year was the very first time that I knew about container because they were made popular by Docker. Docker was launched in 2023, and I was really impacted by presentation of the guy. I said already many times by the creator of Docker. They said, this way to assemble software into packages is great because we make everything much simpler. You can download pre-compiled, pre-built package from the internet and just run. And I had this idea, but let's use for pipeline because in the pipeline we have exactly the same problem, not just for all the pipeline, but the idea was just encapsulate all the dependencies in a single job into a container so that would simplify all the problem installation on the pipeline dependencies. So basically, too many things.
No, I was going to say, I can't emphasize how early you were in having this vision as well. And also one of the things I like about Nextflow is it lets people progressively get to that point. When I started using Nextflow pretty early on, and I knew about containers, I'd heard about Docker. It was something that people used for websites. I think I wasn't really sure. I used environment modules on my cluster, and Nextflow supported environment modules. So that's how the first pre-NF core pipelines were built. They all had environment module support. And then I sort of started using Conda, and that was better. And then I was this Docker thing sounds quite good, and Singularity. And now I can't imagine going back to that. like the amount of time we spent getting the environment module system to work and all that stuff. And even then, the NF core pipelines for a long time, we'd have one container for the whole pipeline, and we still have to solve issues with installation incompatibilities and stuff. Now, finally, it took us about 8 years to catch up with your initial idea of having one container per process, and now it seems obvious.
Exactly.
Anyway,
indeed.
sorry.
With Nextflow, then there was always the idea to use container, even though we didn't want to have as a mandatory component of dependencies. It's supposed to be something that could be used if you had the container, or otherwise, like you were saying, you could use other packaging system, like Kunda or other tooling. But yes, and then become more and more popular container. I think nowadays are an essential piece in any bioinformatics pipeline, to not say any piece of software.
Absolutely. Marcel's having some video issues, but hopefully you're still with us with audio. Apologies if anyone's watching just had an epileptic fit based on, on what's going on there.
I have no idea what happened, but I'm back.
Right. So Nextflow uses it one container per process is the standard way of doing it. One task in a pipeline uses a container. That's good. Everyone uses it, or most people use it. What needed to change? What's the problem with this current setup?
Well, the main problem, exactly like you said at the beginning, we were envisioning just one container for all the pipeline execution. So it was not too complicated. Create this container using the common tooling. So you just create Dockerfile, you put all your dependencies there, and then you run your container, your pipeline with this container by the different tasks. But then more and more, this creates some problem because you create this huge container having many different pieces of software, can be complicated to create, and above all, become too complicated because the number or dependency the pipeline, it become more and more big. So for example, now we have this pipeline and first pipeline, I don't know how many jobs there is in a RNA-seq pipeline. 30,
I think
40?
RNA-seq has 50. I think it's got about 50 different.
Exactly. And there is at least the same number of software tools that are using to by the different tasks your pipeline. So pipeline developers start to assemble and to use different container for each single job, or even different container for each single job. It is created a new problem. The problem that you need to manually create all these container for all the jobs that you are in your pipeline. It's true that there are fantastic solutions like biocontainer that create a direct mapping for each single tool. That automatically create a container that contain that tools and helps a lot, but still is not a general solution because there are some cases, for example, you want to use more than one tool in the same task, and that you need to create a special container that contains these tools because it's not available out of the box. And then also maybe you want to use the latest version of a tool, it's still not available on Conda, this kind of problem. So as the container become more and more popular, what was simple at that time become more complex because we move from the problem of assembly just single container, the problem to manage the building many different containers, maintaining different version, push it to different registry, because maybe just the Docker app was not enough anymore. Anybody start to use their own container, or maybe they want to use in their own cloud. So the problem become keep updated all these container used by the pipeline and create all of them over time. It create another amount of work that usually we would not like to have the pipeline developer to take care of.
And I mean, that's what we do in NF Core currently. Is we use a Bioconda package, and then we use the equivalent Docker image from Biocontainers, which is automatically built. And like you say, that works very smoothly until you need two different tools. You need like BWA and SAM tools, or something and something, and then you have to go off and you have to make these mold containers. And it works, and we use it, and but it's not trivial. Especially for people.
There's a lot of big jobs now to maintain all these configuration for each single job into your pipeline. You have to have different version of the container, maybe one for Singularity, one for Docker, another version for the multi-package container, and then the Conda. So too much work. We want to make it simpler.
So what did you do about it? I feel like you're about to come up and tell us what the solution is. We're waiting. What's the answer?
Exactly. But the answer is wave containers. So this idea that we move away from the static building of containers, instead we move to the idea of provisioning containers. Provisioning containers, the meaning that we can assemble, deliver on demand the container needed by the pipeline. As the pipeline needs a specific tool, a specific container, we can assemble the container on the fly and deliver during the pipeline execution. So this makes the process much more simple, much more smooth, removing all this noise to have to maintain all this container independently, essentially.
Okay, and so what does that look like in terms of, I'm a pipeline developer, I'm using Nextflow. What do I write? What do I have to do to use this?
Super simple. There are two different ways that you can do this. If you use Nextflow modules, one basic way is that you just deposit the Docker file of the container that you want to be assembled or executed along with that task. And essentially, having this Docker file into the level of the Nextflow module, you need only to enable the Wave service into your Nextflow configuration file with the settings wave.enable equals true. And that is basically enabling that when you launch the Nextflow pipeline execution, Nextflow will figure out that that module contains a Docker file, take the Docker file, send to Wave, we'll start building on demand a container and give back a unique container name only for that container. That, of course, is a checksum and is cached. So each time that you repeat the same job execution, that container will remain always there. So it's not built every time. And then essentially we use this container is injected into the configuration of the pipeline on demand and is used during the pipeline execution. So essentially, you use this way, and there is an even simpler approach. The even simpler approach, instead of using Dockerfile, the idea is you just use the Conda package name into your pipeline and configuration. So you just need to annotate all the jobs into your pipeline with the corresponding Conda package or Conda packages, because you may want to use more than one. And then Nextflow discovered that Conda package name and used to assemble a container on demand using exactly the same approach. So it's completely transparent and super fun.
And that can be any Conda package. It's not just Bioconda. You can use Conda Forge or.
No, you can use any Conda package that are available. Yeah.
Amazing. So that opens it up well beyond what we have with biocontainers as well, because.
Yeah, by default, Nextflow include the default channel and the Conda Forge channel, but as long as you specify the Conda package name with fully qualifier, that is, for example, bioconda : multi-QC, you can access the bioconda channel and specify any other channel you can access tool in the specific channel that you have specified.
Good choice of example. So that sounds pretty good. So we don't have to think about Docker anymore. We don't have to specify Conda, Docker, Singularity. We just specify Conda, and then we automatically have, because presumably then people can still use Conda support locally, natively if they want to. But then if they want to use Docker, and this works with Singularity too?
Yes, exactly. It is exactly the idea. Conda is a fantastic tool. There is a lot of software pre-built, ready to be used. But to tell the truth, when you use locally, it's a bit slow because you need to resolve all the dependencies, especially if you don't use Mamba or Micro Mamba, and that are much faster compared to the classic Conda packaging tool. But still, there are some weird behavior because maybe dependencies that don't resolve in a consistent manner. There is some conflict in your local environment. So instead, we have figured out that we can automate all this process, streamline, moving into a service that does exactly only this. We pass the content package we want to use into the pipeline. We create the container on the fly. We send back to the pipeline execution in a complete transparent manner. And like you are saying, we can do the same for Singularity. Singularity is a container engine specialized for HPC, and he has its own container image format. It's true, you can take a Docker container, convert to Singularity, and Nextflow does it automatically, but still also this is not super fun. Step takes some times, and if you have many containers, you have a lot of overhead converting this container from Docker to the Singularity image format. Instead, we also allow to create the same image on the fly for Singularity using the native Singularity build format. So you can switch exactly. If you want to deploy your pipeline in, I don't know, AWS batch, you just take the Conda tools and we create on the fly all the container. If you want to run in HPC, we can do the same with Singularity.
That's a big advantage because we see people coming up with that kind of problem due to the Singularity builds locally a fair amount, where it's taking up a lot of CPU on the head node, the cache is taking up a lot of space, and it's to do with this conversion from Docker to Singularity format. So downloading Singularity format natively is going to be a big speed up. That's cool.
Yeah, also it's very cool because I think one nice thing that is not very well known, that recently Singularity and Obtainer, that is a fork of Singularity, they both support the ability to pull Singularity native images from Docker, or better said, OCI native registry. So basically, we can use the same registry where we keep container images also to store Singularity images. They are not compatible with each other. You cannot run a Singularity image with Docker, but you can use the same registry to store both images. And this is quite nice, I think.
Nice. And for anyone who's using other container technologies like Charlie Cloud or Shift, then you'd pull the Docker image and converts as currently.
Good point, Charlie Cloud. I think yes. Yeah, basically, you can rely on the compatibility on Docker. Yeah.
Amazing. Okay, so we've covered roughly what it's doing. It's building containers on the fly. You touched on it, but I'd like to ask you again in a bit more detail that there's some kind of level of caching, because when people ask us about using Conda in the community, we say Conda's great, but it's not as reproducible as using containers because they build differently and it's system specific. Here we're removing the system specificity because it's the same base container every time, so that's already an improvement. But could you tell us a little bit more about how caching works?
Yes. Before, I want to highlight one point. Maybe we'll expand later, because you said, okay, basically we build container. True, we build container, but even better, we provision container, because I want to be more precise. It means that we does two things. One is built-in container, and the other is augmenting container. And meaning that I can take an existing container and then expand the content without rebuilding. In some cases, Nextflow can do also this. For example, when your pipeline model contains some specific script, and we need this script to be deployed to run into the job execution context. So when this pipeline or use the script running in the local computer in the shared file system, there is no problem to take this script and mount it to the container. It's much more complicated when we want to deploy the execution into the cloud, because the cloud, there is no shared file system, and usually it's a big mess to have access to module log a script into the job execution context running the container. In the legacy version Nextflow, this was done with a ugly copy of this file from the local storage to the bucket, then the container. So, but it was quite fragile. And one reason also that brought us to create Waves was to add the capability to extend on the fly a container at the new binary script, for example, the one used by the pipeline on the fly. And this process is super fast because it does not require the building of the container. It's just an extension of the existing container. So this was just to highlight, because there's always this misconception, every time you build new container. Not always. Only if
inject
you
layers.
Exactly.
One interesting way that you use that was for Fusion, right? So when you want to use Fusion, the content needs a Fusion client.
Exactly.
And you add the Fusion client augmenting with Wave, right?
Exactly. Yes. Fusion basically is a file system solution that requires a client, a binary client, to be executed into the container context, into the job context running into the container. But we didn't want us to pull Nextflow maintainer and developer, okay, now if you want to use Fusion, you need to rebuild all your container, would be a nightmare. The idea was giving this ability. So just using this mechanism on Wave to take the existing container, adding on the fly a teeny layer that contains only the client that need to be executed.
And I think there are many more examples, right, of ways that people need to augment their containers, and Wave brings this.
I didn't understand, sorry.
So I believe that there are many other examples, right, that people need to augment their containers by adding a tool or some authentication or some other things. Do you have any other examples of people doing nice things with this augmentation?
Then the main example are things we use essentially for the extended container with the pipeline script, the Fusion driver, the client, and there are some other examples using logging agent that can run into the pipeline job. So into that can be useful to stream the logs from the container job container to a daemon, or maybe to run other services. Yeah, but just these are the main examples.
Yeah, but I think that was one of the things that people missed with DSL2 is the ability to have a bin directory where you can just sort of put binaries. It's nice to bring that back.
But I didn't want to avoid your question about caching. How does it work? It's very simple. So basically, when there is a container built by Wave, essentially what is happening is just take the Docker file or the container file, that can be Docker or Singularity file, and we create a checksum on the container file along with the target repository where the container is going to be uploaded, and the platform, meaning that if it's a container for Intel, it's a container for Graviton, and it's create a checksum. And this checksum become the unique identifier of this container bit that you have created. So every time that you continue to use the same Docker file or the same Conda packages that create the Docker file, you get always the same container. And this container is stored into a repository that we maintain behind the scene, unless you want to specify your repository. So if you want to keep all these images in your own registry, you just specify in the Nextflow configuration file where you want the images uploaded, and they will stay there forever. So as long as you continue to use the same packages, you will get always the same container.
And that's also nice to be able to use your own private registry, because that's something we recently in NF Core, we changed how all of the containers are specified so that we use a single registry.base URL, which is set to key.io by default. And one of the reasons we did that was so that people could switch that out to their own private registry. Because there's more people, especially big companies and clinical uses, are getting more careful about security. They like to maintain their own Docker registry so that they can keep track of it. And now you can just point Wave at your own private one. That brings me nicely onto another thing that I believe Wave can do. Tell us a little bit about how Wave handles authentication.
Yes. So basically, yes, this was another reason why we created Waves, because Nextflow is not able to authenticate for the use of private container. And so how we solve this problem? Essentially, we move all the authentication of the container into the Wave backend side and integrating the authentication with the Tower platform secret management system. So that imagine that you have a private repository where you want to keep your container, or you want to use your container. You keep the container private and you want to use into your pipeline. Essentially, you set up the credential of the container registry, your private container registry, into Tower. Then, using the Tower access token, you can specify it into the Nextflow configuration. So basically, you grant access to these the container secrets, the container credential, registry credential, to Wave that will access through the Tower access token. So what is going to happen that when your pipeline will try to access a container image that is stored in a private registry, Nextflow we call Docker will call Wave. Wave recognizes you because you specify your token into the Nextflow configuration and will ask for your credential to Tower. We get the credential, authenticate the access to the target repository, and then we give access to that container image to Wave that we give access to Docker. So it's basically is a proxy mechanism. We use Wave in the middle between Nextflow, Docker, and the target registry to authenticate the container.
I think that one interesting thing about authentication is that a lot of people think that the only reason they would need authentication is when they are like they have a premium account on Docker Hub or something. But actually, I think that if I remember correctly, starting in November, anonymous users will be limited to 100 container pulls every 6 hours, and free users twice that, 200. So even if you have a free user, authenticating yourself is much better than remaining anonymous. So Wave is very useful for that. Even if you're not an enterprise company, you don't have like a paid account on Docker or anything like this, the free user, Wave is still very useful because you can double the amount of polls you have every 6 hours.
Yeah, indeed. Docker is not free anymore. In the meaning that it's not free anymore. The free access quota are very low. If you want to access at scale, also for public containers, you need to authenticate your pipeline execution. So you manage this manually. This can be done maybe in a single computer. This is possible, but when you deploy this into a cloud cluster like AWS Batch, or you use native AWS container registry to authenticate your container, or you can use Wave if you want to use a generic container registry.
I'm just trying to follow all the logic. It sounded complex, but I have a feeling it's one of these things where I'm never going to need to care about how it works because Wave does it all. especially if I'm running Nextflow in Tower. Tower is already authenticated by default. All I have to do is click add credentials and the stuff should just work.
Exactly.
Right? That's what it comes down to. That's nice.
Yeah.
One last thing I think have on the Wave sort of backend. You touched on this earlier, and I wanted to sort of pick up on it. When we were talking about caching, you said it's based on the hash is based on the Conda packages that you build with, and you also mentioned something about architecture with Intel and ARM.
Yes.
Can you elaborate a little bit on what's going on here? What are these architectures? What does that mean, and what is it that Wave's doing?
Yes. So we are moving away into a computing world in which there is only one single CPU architecture. That was Intel until a few years ago. Okay, this never has been true, but the dominant architecture has been for many years Intel. And in the last 5 years, becoming more and more common to see other CPU architecture, mostly driven by research in mobile and to mobile phone that create this new CPU architecture that consume less energy. It is starting to be more common also in cloud farm, also in our desktop, because most of us nowadays use Mac computer. Mac computer now in the last 2 or 3 years is starting to use the Mac Silicon CPU that is essentially a ARM-based CPU that came in from the mobile industry. And what's the difference? Okay, they have different CPU set. This means that the container that was created for Intel is not going to work anymore, because all the content, the compiled tools, has been built, compiled for Intel architecture. So if you try to pull and run in your computer, your Mac, the container, it may fail unless you specify to enable the compatibility layer on Mac that allows you to continue to use the Intel binary, but because you are basically using an emulation layer. But this is not going to work in any case if you want to run this container into Amazon Graviton, that is a similar architecture in the Amazon Web Service cloud. And so essentially, when you run container, when you deploy a build container, you should also specify the architecture, the target architecture for which the container has been built. And we can do this on demand also with Wave, because this makes part with this idea that we want to make the pipeline portable across different computing environments that can be different cloud or different infrastructure, but also different CPU architecture. So we want to make it possible that we can take the same pipeline or NASIC, whatever, and just switching our configuration setting, we can say, okay, I want to run this on Intel, maybe I want to run this on Graviton. Doing that, we are able to provision or reassemble container on demand so that we can deploy the pipeline execution from a HPC based on Intel to Amazon Cloud using Graviton, for example. And Wave takes care of provision the container for the specific architecture where you want to run.
Very cool. Again, coming on the community side and also speaking personally, that the M1 Mac thing is like, you see more and more people using Gitpod or other virtual environments just so that they can test their pipelines on an Intel system. So having better native Mac support would be amazing, especially if you don't really have to do anything.
Yeah.
Very cool. Okay, and so basically, one container, one software container can effectively have multiple different architectures, and we can deliver the appropriate one for the system that's running it.
But in real world, what is going to happen that there are many different images with the same name. Each of them has a different annotation that specifies the architecture for which has been built.
Cool. This is sounding very cool, obviously. I mean, I'm also thinking that this maybe goes beyond just Nextflow, right? This is a technology that's being built not really about the pipelines. It's being used by the pipelines, but it's built around container technology itself. It's kind of a step up from that. Do you have any sort of plans or ways that other people outside of the Nextflow world can use this technology?
Yeah, exactly. We with create this technology having Nextflow in mind, having a deep integration with Nextflow, so that for the user was completely transparent. It was really just setting up a couple of configuration option to the Nextflow configuration file to enable this technology and nothing more. Well, at some point we realized that this can be useful also outside the context of Nextflow, and we want to make it accessible to any other developer or even pipeline framework. Why not? I don't know, maybe Snake Make want to use wave containers. And we started, for this reason, we created also a separated tooling that is we call Wavelit, that is a command line, basically a little command line over the Wave API. And this allows you to use all the Wave functionality from your terminal. And this can be used for integrating into other script or just to experiment with the technology to get used to it.
So what is it that Wavelit does? It's basically kind of doing the same calls for Nextflow would do.
Exactly the same. Yeah, maybe even a bit more actually, because you can create also container in a more free manner. But maybe I can just show you how does it work, because it's so simple that maybe the best thing to do is to explain what it does. So Wavelit is a command line tool that you can download from GitHub. It's an open source command line tool. We compile natively for Mac, Windows, Linux, so you can find your favorite flavor, and you need just to download on your computer, and then you can run with Wavelit. And the most basic operation that you can do with Wavelit is to augment a container like we were doing before. And to do that, you can just say Wavelit -i, and the image name that you want to augment, that maybe is Ubuntu. And this basic operation is doing called the Wave server. It just return the Wave container name for Ubuntu in this case. And in this case, we have done basically not much, because we are just asked to Wave, using Wavelit, to access a container. This is a public container, so there is no benefit, but in this case, the only advantage that could be interesting, if this was a private container, we could have access through Wave without using the credential, or using the credential that were stored into our Tower Credential Manager. And so what I can do is just pull this container, and nothing more. This is just running an Ubuntu image. Here, the interesting thing to see, if I try to pull the same container, instead of using the Wave container name, but just using the basic Ubuntu container name, the two containers have exactly the same checksum. And this shows that basically Wave is not building unless you demand. The container is not modifying the container unless you demand. So by default, it's just giving an alias that pass through Wave for the same container. This is why they have this checksum. And then, but can be a bit more interesting, for example, to show how Wave augment an existing container. For example, let's say that I want to add some content to this Ubuntu image. I could create a directory in my computer that I call new content, and then I just create a file that contains the usual hello world. I want to save this file into my local directory, because then I want to include this local directory into the container. So I pipe the content, redirect the content of the echo word into hello.sh. I give execute permission to this hello.sh script. And then how to make it possible to move this directory structure, on this case, just a simple file into the container. So we know that we could build the container, but this is not the point. We want to use Wavelit, always using the previous Ubuntu image. And now I can use the flag a ---- layer With this option, basically, we are telling Wavelit, take all this directory and append to the Ubuntu container on demand when the Docker client is pulling this container. So I just say new content. Again, Wavelit, give me back the name of this container, the wave.seqera.io, a random number, and then the container name. And then when I try to pull this, I will find out into this wave container the new content, ls la slash. And this new container contains the hello.sh. Of course, this could have been done in a much simpler way, just mounting my local computer this directly, but this is not the point. We are doing this to show how I can transform a container in a new content, new layer, and then can be pulled independently from a remote cloud executor, for example, without the need to build this container image.
So we're not binding local files here. That file's being copied into the Docker image.
Exactly, absolutely, yeah. And again, this is without building the container, but I can even build container if I want. I could create the usual Docker file, and again, I want to have a basic Docker file where I can declare from Ubuntu latest. And then I want also here to create this .lo sh file. I want to put maybe into user local bin hello.sh. And then I want to execute the command .lo.sh. So in this case, I have a proper Docker file. I can use Wavelit to build on demand this container. This time we are doing a real build.
Are you missing the new content directory path there? In the Docker file, do you need new content slash? I think it might be a typo.
From what to, why I need to content? No.
Because you put the script in your local directory called
okay, but this is interesting what I could show you. Let's say that I run this with Wavelit minus F, in this case, Docker file. If I try to run this, actually, I will get an error. Exactly for the reason that you are saying. Because it can't find the hello.sh because I didn't put the path. But the point, I didn't put the path because in reality, what I need to do, instead of specifying the Docker file the path, I need to specify on the Wavelit command line the option to tell where is the directory contain that file, the context basically. In our case is context.
Also, again, for anyone listening without video, I think that's quite interesting. So you ran Wavelit with a problem. It gave you a Docker URL exactly as it did before, as if nothing was wrong. But when you tried to pull it, Docker itself complained that it didn't exist. It tried to download it, and then it showed you the error, and that error is coming from Wave, right? That's the Wave build error that just showed up from Docker. So you've passed the error message through Docker somehow.
Yeah, basically Docker report the error message of the Wave backend when it tried to build the image. And to close this example, now I can run this version, and now I have the whole word because basically the build found the context containing the hello.sh script. And so this shows basically the two basic operation with Wave, the augmentation that does transform a container without building or building with a Docker file. I want just to show the final example, maybe how to do the same with a conda package or more than one conda package. So if I want to create on the fly a container with a conda package, I just can say conda package. And for example, I could say batutools. Don't remember what is 130, the latest version, maybe 230. This is enough to create the container on demand containing bed tools uses the Conda package for bed tools. Here, you change a bit the URL, and now is wave.seqera, and we have Wavelit, and there is also the name of the tool in the image, because Wave is enabled to interpret the name of the Conda package to use it for the container image name. So we're going to run this. I can run this, but tools version. Here we go. And here we are. We are running bed tools within this container. I can do the same with any number of Conda packages. I can say again Conda package. So both Conda package for bed tools, but a Conda package for some tools. In this case, I want to use version 1.17. So now we have a container that contains both these packages, because behind the scene we are running Micromamba that use these packages and build the container for me. And again, Docker run.
And how long will these images exist on Wave?
Second, complete the command line. Complete the command line to run some tools. No, I made a mistake. I missed a typo here. Wave. Okay, it depends. Can take in average, it can take 4 minutes. So it's quite fast compared to the local execution. But here I can show you an interesting thing. You see, now I'm pulling the container, and for a few seconds it didn't do anything. So the Docker run just stopped. And what it was doing, basically, we have added to Wave this capability to, instead of making Docker returning an error, when Wave is building a container, the Docker client just stop and wait for the container to be ready. So this makes it possible that we can run this on demand during the pipeline execution without interrupting the pipeline execution, because the Docker client, we just wait for the build to be ready, essentially, even if it's not yet ready. And like I was telling, this can take 2, 3, 4, maximum 5 minutes. Well, also, the nice thing that, well, yeah, go.
Let's say I create this container image with some tools and bad tools. Okay, so now I have this URL for this image in Wave. How long it's cached there?
Okay, in our own registry that we keep by default is kept only for 2 weeks.
Okay.
But this can be changed. Simply specify your own container registry. And in that case, we say, depending how long you decide, by default, forever. So since we are a lot of people using this service, we don't want to store everything forever without reason. It's just a transient cache, but can be made long as long as you want to. That is just enough to add a new command line option. So if I want to use my own cache, I could say build repository, and the same on the Nextflow configuration file. And then you can specify docker.io, for example, your docker.io registry, your ECR registry, whatever. In my case, I could say Paolo Di Tommaso wave test. I made a mistake. Build repo. I don't remember. Okay, it's build repo. Here we go. We have the same image, but now this is cached basically into another repository.
Nice. And I thought it was also quite interesting when you were pulling the new container that you made then, that had both bed tools and SAM tools, that most of the layers were cached as well. So it was really only just the new bit on top that you added, which actually had to be downloaded.
This is also can be quite fast. in some cases for this reason, because it's cache independently the target images, but also the intermediate layer. Also, there was some debate about why Wave is using this weird name. I would like to use my own registry name instead of this temporary name that is given now, because each container has an ephemeral name that is Wave, Seqera.io /number / maybe the container name, not maybe the container name. But still, it's inconvenient for some user because they would like to have a more predictable registry name, image name. And this is possible with this new feature that we call freeze, that basically frees the container into a permanent image name. The practical term means that you need to specify a freeze option on the command line, Wavelit command line on the Nextflow command line tool. And you see now the resulting container name is docker.io. So exactly the registry that was specified, the repository was specified on the command line. And if you don't touch into your registry, this container will stay here forever.
Yeah, and then you're not putting anything you do downstream would not interact with Wave at all after that point, because that's just
exactly.
a regular Docker image.
And let's close maybe the demo at this point. Added the Singularity option to show how we can build a Singularity container. Here we go. We did. So this is the container name that can be used by Singularity. In this case, the only difference is start with the pseudo protocol or as : //. So this is basically a pseudo protocol that allows Singularity to upload and download Singularity image file format from an OCI container registry. So I could take this and pull and run. Or not Docker, but Singularity exec. This will take, this likely is going to fail because that tools version. Because Singularity doesn't implement the capability that I was explaining you before to wait for the container to be ready. So until this container is not going to be ready, so basically now we are getting an error, but if we wait 30 seconds, we'll be able to run it. But essentially, this is the operation that you need to do to build a container with Conda for Singularity. So the Conda package name, the target registry repository where you want to upload, the freeze option, and the Singularity option. This is enough to create a native container for Singularity with any Conda package or packages. Let's try it again.
Is there, if I'm building my new container and I've made a typo in my Docker file or whatever, I mean, I can see the error message from Docker at least when I pull from Docker. Is there any other way to sort of have debugging information or know that the container build failed?
Well, if you provide both to Wavelit command line tool or Nextflow configuration file your tower access token, you will get an email that contains all the log of the building. That helps a bit to debugging this.
We'll have to see where this goes in terms of kind of what functionality we can use this for. But I can see this is going to be immediately useful for people running in kind of protected environments and stuff from day zero.
I think it dramatically simplifies all the assembling of container images. So instead of having to maintain a collection of images for each Conda tool or rebuilding if you want to add a single script, all this kind of stuff is super annoying. Also maintain sometimes different registry because you want to deploy multi-cloud. So if you want to deploy in Amazon, you have the container registry collection into Amazon ECR, or if you deploy in Amazon, you want to maintain also there because it's faster to move the images from within the same cloud. Maintaining independently is a bit nightmare. Well, with this system, it's super simple to to mirror one set of images from in any register that you want.
Yeah, because Amazon has the ECR copy of biocontainers, right, where biocontainers are available on ECR for that reason. There's also the question of cost as well, because you don't have data ingress costs if you're using Amazon ECR versus an external registry on the web. I think that was one of the things that we were doing on NF Core, where people can change a base so that they can use a container registry on their cloud, wherever their cloud is. But now you're saying we don't even need to touch anything in the pipeline code at all. Like any container registry will work. All you have to do is just tell Wave, just use Wave, and it will be built and cached in the right place.
Exactly.
Nice. Right. Thank you very much for that, Paolo. That was a fascinating insight into some of the new stuff that's being built around container technology. Such a core piece of infrastructure for all this kind of modern data science. So it's really exciting to see kind of innovation happening, and especially the kind of stuff that I love, which is making life easier for people using the technology. It's all about simple interfaces and intuitive usage.
Yeah, exactly. First of all, thanks for giving the opportunity to present this, and yes, you get the real motivations of what we are trying to do to smooth as much as possible the experience for pipeline developer and Nextflow developers, so that they can focus on the main logic of the pipeline more than assembly container, pushing container is super boring activity.
Yeah, exactly. And maybe I think we'll try and get you or someone back soon to talk a little bit more about Fusion as well. We touched on that once or twice. I think that probably deserves a podcast episode just to itself, because there's lots to dig into there.
Yeah.
Quickly, I'll wrap up at the end with our kind of regular points about kind of content and upcoming events. September has been a month of training. So if you're interested in getting trained up on using Nextflow and building with Nextflow, we've done the foundational training at the start of the month. That was 3 sessions, which are all up on YouTube. So that's updated to match the latest copy of the open source training at training.nextflow.io. Marcel, you've got some training soon, right?
Yeah, in the next day, we're going to have at the mid of September, the hands-on training. Yeah, it's going to be fun. It's a new training material. It's really nice. It's quick, hands-on, good for people who are trying to remember what they knew about Nextflow and so on.
I've given away a glitch in the timeline, because I just realized actually it's already happened by the time people were listening to this podcast. But so it happened a few days ago, and it's up on YouTube, and I'm sure everything has gone very well. And then there's the advanced training coming up at the end of the month, 27th to 28th of September, which is the first time we run this online. So lots of stuff to get stuck into. Pick your kind of experience level and even the amount of time you have available to get stuck into Nextflow there. And then the Nextflow Summit, the kind of big highlight in terms of our community events. Registration is now sadly closed for Barcelona. So hopefully you got your ticket, but and the Boston registration is slated to close on October 27th, or when tickets sell out, whichever happens first. And I think the way things are going, the tickets are about to sell out any day now. So please get in fast to get that. And we're really excited. The program's live. Everyone's starting to kind of tweet about their talks, and we're starting to see highlight that you can sort of feel the buzz building. It's not long now. The countdown's on.
It's a long-awaited event every year, right? I mean, like a party, a celebration for the whole community. If you like this demo, there are many other demos, like a long demo that Paolo every year shows all the new things in Nextflow. It's great to be there, and see live all these amazing things that we're gonna see soon. So if you have never been to the Nextflow Summit, you have to. It's an amazing event.
Looking forward to it, Paolo. Do you know what you're going to talk about yet? Is it top secret?
I have some ideas, but it's make part of that my presentation.
It's guaranteed to be. With your history of live demos, I'm expecting great things. Right, with that, we'll wrap up. Thank you very much, Paolo, for joining us and telling us all about Wave. Thanks, Marcel, for joining. And thank you, everyone else, for listening in and joining us on today's podcast episode. We'll see you in a couple of weeks. Thanks.
See you soon.